Okay, in this next section we're going to get into adding, first we're going to look at adding a diffuse map, a map to the diffuse channel. So I'll just close the edit parameter interface. And we're going to need to take a look inside of our node network. So there's two ways to get into the network. We can look actually at the node itself, which is the Manta surface node. Now notice we have a Manta surface 1 in here too, which is the original Manta surface, and this one's called Manta surface as well. I think probably the first thing we should do is rename this. And I'm going to call it Quick Shade. The reason why I'm going to call it Quick Shade is because I think having this interface really quickens your ability to shade an object. So I'll turn on diffuse and color here just to make sure it's working. Yep, there we go. So there's our Quick Shade node. We can double click it to get inside the network, or we can go to the material palette and double click the material to get inside the network. Either way, when we look inside the network and just maximize this pane, this is what the network looks like. Now it's pretty complex, especially if you're not familiar with how node networks work. And if you're new to Houdini, this can look pretty intimidating. So here's what I want to do. I want to start by describing exactly how this is working. There are two main outputs, the displacement and the surface. The displacement is obviously actual changes in the positions of the pixels on the geometry, so displacement. And then the surface model handles everything else, including the channels we looked at, diffuse and color and luminous and specularity and reflection and all those channels. And they all plug into this humongously huge kind of root node. So all of these things plug in. So for example, let's look at diffuse color. So if we want to know where the diffuse color is coming from, we simply follow this line up here, and we can see that the diffuse color is coming from this node. And we can see what is inside this node by typing P, which opens the parameter interface for the currently selected node. Now we look inside the diffuse node and we see it's got a name, diffuse color. It has a number of parameters. Each one of these inputs is one of the input parameters. And input parameters can either be altered right on this parameter interface, or they can be promoted up into the interface that we've been designing. And when they're promoted, they change color, because if you remember, this color coding means that this is channel reference to somewhere else. There's another way you can tell that this is controlled somewhere else. If you look on the left side of this node, you can see that there's these funny little dots. Some of them have a direct node inputting into them. For example, color map width has a line going right up to this input, which is called bump map width. Now I can collapse this simply by middle clicking on here and saying hide input nodes, and you'll see it turns into one of those little bumps. Now all of these bumps have been promoted to the interface. So if we want to look at all the inputs for this node, we can simply middle click on it and say expose input. So I can do that with all of these. These little dots are a way of simplifying the interface, so you don't have to have all these nodes inside here. So we could do that with all these, but there's no need. I'll just go ahead and collapse those back down. Hide input nodes. Hide input nodes. These lines here mean that there's a number of nodes out here that are being hidden away right now. So if we, for example, the S and T coordinates, which are for UV mapping, are coming from a UV node that isn't visible right now. So if I go ahead and expose the input for S and T, we'll see that they all go to a UV coords node. Just undo that just to clean up. So you can see wherever S and T are visible, there's just lines indicating that what they're connected to is currently hidden. And that's a way of trying to keep this whole node network pretty simplified and clean. Conveniently, they have arrows on the lines, and the arrows tell you the direction of the flow. So it should be pretty easy for you to pick any channel and follow it upstream and see where it's going. So to begin with, let me just go back up one level, and I can go back up by typing U, and that brings me back up to my interface. I want to look at my diffuse. So I have a diffuse intensity, but I'd also like my intensity to be multiplied by a map. So I'm going to go back into my node by typing I for in, U for up. I'm going to look for my diffuse intensity. Diffuse intensity, there it is, and it seems to be controlled by one node. Let me just expose that node so we can see what it is. Where'd it go? It went way up here. That happens sometimes. When a node gets exposed, it goes way out of whack. So just bring it in a little bit closer here. So there's our diffuse intensity, and we know that this node is being exposed in our shader interface right here. Diffuse intensity. So what I want to do, as I said, is I want to multiply the diffuse intensity by a map. So the first thing I need to do is put down a node that says there's a map. And the node that we use for that is called surface color. So I'll type tab, and that tab menu gives me access to all of the nodes. But I don't want to hunt through them. So you can type to search at the top. I'm just going to type SUR, and it goes straight to anything with SUR, and all there is surface model and surface color. Well, surface model is this humongous one over here, so we're going to pick surface color. That's the one that we want. I'll just move it down so it's not conflicting. So I want to multiply this surface color by this diffuse intensity. So I'm going to change this name to diff map. It's always a good idea to name your nodes unless they're generic, and that'll help you when you're digging through your network trying to figure out what you did later on. So we want to multiply the diffuse intensity by this map. Now we haven't set the map inputs up yet, but we can set up the outputs. So multiply is fairly straightforward. Type tab again, MUL, to get the multiply node, and just drop it down here. I'm going to plug the diffuse intensity input into the multiply node, and I'm also going to plug the diffuse map color output into the input. And then I want to plug the output of the multiply into the diffuse intensity. So now diffuse intensity, rather than just being one slider, is going to be a slider multiplied by this diffuse map. Now we need to create the inputs into diffuse map, and we need to get them up into the into our interface. And here's how we do that. We want to use the map. We're not using base color. We're using a map. So we're going to use the base color map. So we want to promote this parameter. So I simply middle click it and click promote parameter, and that creates a collapsed parameter that exists up in the interface. So let's just deal with this one input to begin with. I'm just going to type U to go back up into the interface, and if I look down at the bottom of my interface, here's the node. It's called base color map. Whenever you promote a parameter, it always ends up way down at the bottom here, and then you have to open the edit parameter interface and you have to rearrange things. Now this is disabled. There's a disable script on it, so we have to figure out what that is. Probably the easiest way is to just simply go back into the network, look at the parameters for this input. So expose it. It's flipped way off. Oh, there it is. It's right here. Let's look at the parameters for this node. So by default it has disable when use color map equals 0. Well, we don't want to disable when right now. We'll put one in later. and that should do it. That should make it visible. This is the same. This is the same exact interface, the parameter interface that we look at when we're looking in the edit parameter interface, by the way. So we can either look at it here or we can look at it up in the edit parameter interface. So let's go back up, and we can see now the color map is not disabled, but we don't want it to be called color map. We want it to be called diffuse map. So let's open the edit parameter interface and find that parameter. It's down at the bottom here. It's called, right now, currently called base color map. We don't want it to be called that. We would like it to be called diff map. And the label is going to be map, just like the other labels for the other channels. And I'm going to take this and I'm going to put it back up in the interface. First thing what I'm going to need to do is collapse a whole bunch of these. They're taking up too much space. Surface. Okay, that's a little bit easier. So I want to stick this right up behind diffuse intensity. If you look at the interface here, you'll see we have a diffuse enable checkbox, and then we have intensity, and map should go right behind it. So I'll go down and I'll grab that parameter. I'm just going to drag it up, stick it in right behind intensity, and I have to remember to select intensity and turn on the horizontally join so that the map comes right after it. And it looks like map has horizontal join on. It doesn't. So I'll apply that. Oh, I see what I've done. Instead of putting in the use map toggle, I've actually put in the dialog, the file dialog, to select which map, and that's incorrect. That shouldn't be there. That should actually be down in the surface in the diffuse channel, right underneath the separator. So I'm going to drag it back down there, and then we'll go and find out where our toggle went. So this goes, it would go under the separator, but if I put it under the separator, it'll be in the wrong hierarchical order, so I kind of have to put it above the separator, and then I have to move the separator up. If I try to put something at the bottom, it'll end up popping out into the wrong hierarchical order. So now this parameter should be down here in the diff tab. Oh, I have to apply it. There we go. And there's the map now. And that should be renamed diffuse map, so as not to be confusing. And now we have to go back into our network and find where our enable button has gone. So yes, I did the base color map rather than the use color map. So that's what I meant to do. So let's go through that again. It always helps to go through things a second time anyways, just to reinforce. Middle click, promote parameter. There it is. I'm just going to expose this one as well. There's our color map. It says it's called use color map. I actually want to change these names of these nodes as well so they're not so confusing. This should be diff map, and this one here should be called use diff map. Alright, so once again we want to change the parameters of this, or the name and label of this node. So use color map 1 will become use diff map, and the label will simply be map to remain consistent with all the other channels. Alright, now I'll go up to our interface and we'll find our parameter way down at the bottom. We'll open up our edit parameters and we'll shove that back up where it belongs. There it is down at the bottom. So we'll push that way back up, right behind diffuse intensity. This does tend to do that. It snaps way down after you've done something. I don't know exactly why. It's a little bit annoying. Let's apply that, and now we have diffuse, diffuse intensity, and a diffuse map. So to review the node network to see exactly what we've done, what we did was originally we had the diffuse intensity plugging directly into the diffuse intensity input of the surface model. What we did was we split it so that two things can multiply to create that surface intensity using a multiply node. Then we plugged in a diffuse map to multiply by the diffuse intensity, and we've added a parameter to use the diffuse map and to choose what the diffuse map is. Now there's several other parameters that we also want to promote to the interface level. Color map wrap, filter, width, and border. And then we also need to get T and S coordinates, which are our UV coordinates, so that the map can be properly applied. So to promote these, first we'll promote these 1, 2, 3, 4 more parameters up. So middle click, promote parameter, middle click, promote parameter. We'll just do this for all 4 of these. Okay, so those 4 parameters are all promoted. Let's go up and take a look at them. We're probably going to want to rename them to be diff map as well, because by default they're color map. So we'll open the edit parameter interface. This time we'll rename these parameters from within the edit parameter interface. So this is color map wrap. We'll call it diff map wrap and name the label to be the same. Color map filter becomes diff map filter. Take the 1 off the end. Same thing with color map width becomes diff map width. It's really very important to name and label all of your nodes logically. Otherwise, you're going to end up getting confused. And once you really get the hang of doing all this crazy node network stuff, you're going to find yourself with hundreds and hundreds of nodes. And if you leave them all at default names, then you have multiple nodes with the same names, and you run into all kinds of logic problems and all kinds of confusions. So it's really worth it as you go along to take care to properly name everything. Alright, those are well named, and now those need to move up into the diffuse area. So let me just collapse these so we can see easier. We don't need settings, we don't need subsurface, refraction. I'll just close all these down. Diffuse, there we go. So we like these parameters to pop right up here. Now once again, I won't drop them on the bottom. I'll show you what happens. So you put it on the bottom and they go into the wrong hierarchical position. So you really need to kind of drop them above and then take that last guy and put it above. It's a little bit annoying, but it gets it done fairly quickly. And when we apply this, we discover now that in the diffuse channel, we have a bunch of diffuse map attributes. Now, you may recall that we had a disable when attribute for diffuse map, and we removed it. These ones all have a disable when attribute on it for color map. We don't want it. We want it to be disabled when diffuse map is disabled. Use diff map, it's called. So we're going to put our own in there. And it's going to be use diff map. And this is where naming your nodes comes in really handy. Let's copy that parameter. Hang going to paste it into the other channels. So now we'll see that the diffuse map controls are all disabled until we turn on diffuse map, and now we'll see that those are all enabled. So I'll just close the edit parameter interface, and I'm going to save at this point. So now let's bring up our panel with our full interface on it. And we have our diffuse, which works just as before. We can turn it on and off. We can turn it up. We can turn it down. Or we can apply a map. And right now it's doing nothing because there is no diffuse map in there. So if I turn on diffuse map, and I'm going to grab that stripes image that we had, and you can see now that the diffuse channel is being affected by this map. We just simply plugged it in, multiplied it by the intensity value, and the nice thing about having it multiplied by the intensity value is that the diffuse intensity is now a multiplier. We can increase and decrease values still multiplied with the map, so one doesn't override or turn off the other. They work together in concert. So if we want the full values of our map, obviously we need to turn our intensity slider up to 1. Now, of course, we can also put color images into this channel, but because we're using luminance to map the diffuse value, diffuse intensity is just brightness and darkness is not color. So if we could put a color map in there, but if we do, it'll still only take the luminance value from the color map to be used in the diffuse channel. So let's go ahead and add map also to the luminous channel. So if it isn't clear to you yet exactly how to do this, it should be. We're just going to go through the luminous and do it, and then you should have it figured out. So I'll minimize this panel. I'm going to go right into the network, and I'm going to maximize this view. I'm going to turn off the parameters, pane P, just so I can see things a little bit better. And what I want to do is I want to add a map to what I call the luminous channel. Let's just go back and look at the interface for a second. So what we're talking about is luminous, what I call luminous. So it makes it look like it's actually a light bulb or something. And there should be a map to that. Houdini calls it emission. But luminous to me is a more intuitive word, so I prefer to use that. So when we go into the actual network of the quick shade, we're looking for the emission intensity. Let's find it here. Emission intensity, there we go. So we don't need to worry about any of this other stuff that's going on around here. All we're looking at is just the emission intensity. And right now the emission intensity has, emission intensity has a parameter. So let's expose that parameter. I'm going to click on it and then right click to say expose inputs. And that's flung way off into space. So we'll go and grab that again. I'll just zoom out and find it. Bring it up to some usable position. Okay, so once again, we have emission intensity. We want to apply a map and multiply it by emission intensity. So the first thing we'll do is add a multiply node. Tab MUL to get multiply. Drop it right down. I'm going to plug this straight in there and plug this straight into the emission intensity input right away. So if we just left this like this, currently it would make no difference. Emit intensity multiplied by no other input is the emission intensity. I'm going to put down a surface color for the next input. Tab SUR, surface color, and you know what, I have some real pausing going on. And the reason I have some pausing going on is because I've left my IPR rendering. So I will pause it. I am really bothered by the fact that when this render view isn't visible, that it doesn't pause by itself. Um, if this bothers you too, you should probably let side effects know. Anyway, back to business. So from the surface color, that's going to the next input. So we're going to now multiplying the results of emit intensity and whatever this is going to be to get our total emission intensity. This is going to become the emit map. So we're going to use a color map. So we're going to promote that parameter. We're going to need a base color map to use. We're going to need all these other color map controls: color map, color filter, width, and border. We're going to promote all of these up to the interface level. And we also need to connect our S and T coordinates, which I think we may have forgotten to do on our diffuse map, so we'll have to do that as well. And in order to do that, we need our UV coordinates visible. So we're going to go ahead and expose these inputs. So I remember our diffuse map that we did for our diffuse. We just need to take our S and T coordinates, take S and plug it over here, grab the T, plug it in there. And we'll do the same thing with the new one we just created for our emit map. S goes to S, and T goes to T. Okay, so now all we have to do is go back up to our interface level and rearrange and rename these inputs. So we'll go back up, and then once again we look at the bottom of our interface. We'll see all of those new parameters that we added. We have to go to our edit parameter interface. And the first thing we'll do is rename these. Actually, the first thing I'm going to do is collapse once again all the channels that we don't need. I don't need displacement. This is on emit, right? Right, under, I call it luminosity, or LUM for lum. Okay, so use color map is going to be called use emit map, and the actual toggle is simply going to be called map, and the base color map is now going to be called emit map. Color map wrap becomes emit map wrap, and the same thing with the other channels. And I think I forgot to take some of these ones off the ends here. These ones, the numbers at the end are automatically created to indicate that there's multiple copies of these nodes. So when you're renaming things, it's a good idea to take them off so we don't get confused and start looking for where the extra ones may be. All right. And then we have this disable when as well. We want the disable when to say when a use emit map is off. So emit map wrap will become use emit map. And paste these in again. Just using the Control V to paste these in right now. And all done. Now we simply have to place them where we want them to be positioned. So the enable emit map button will go up in the top interface. So we have luminous, emit light, intensity, and then it's going to go right after that. And And you may remember that we have to go back to our intensity and turn on the horizontally joined to next parameter. And then we want to take these remaining emit map parameters and we want to put them in the tabbed interface, which is where all our advanced controls go. Right now there's only one thing in there, emission color. So we're now adding map. And it's at the wrong hierarchical level, so once again we have to put it on top. We have to take our color and drag it back up to the top. And I'm going to put a separator in between those two just to make it obvious that they're separate. I'm going to apply all these and minimize my edit parameter interface and take a look at my parameter and see how it's working. Okay, so in my luminous I have a map control which should be disabled when luminous is disabled. So I need to put my disable when on that. Let's do that now. So the emit map, it needs a disable when, and it needs to be disabled when emit enable equals 0. So we can actually probably just copy it straight off of one of the other parameters. We actually have one reflection. Oh, that's the wrong one. Intensity has when emit enable equals 0, so we'll copy that right onto map disable when. And while we're at it, we may as well put the callback script on as well. So we'll just copy that, Control C, Control V in the callback script. There we go. Make our interface work nice and slick. Okay. So now, here's the full interface. We enable map. All the map stuff goes on. Oh, that's the color map. Let's try it with the luminous map. Luminous map. There we go. Okay, so I'm going to unpause the IPR. And luminous is on now, so we expect it to become luminous, which it does. And map does nothing since there's no map applied, so let's add a map. Let's pick that airplane picture map. Okay, so that is changing the emit intensity. Now we could put the same map into color. There it is. And now it's emitting with the color. Or alternately, you could, instead of plugging this into the emit intensity, you could actually multiply it by the emit color instead and get colored emissions coming out of there. Either way, it's basically the same process to multiply the existing values by a new map that you're plugging in there. So now what we have is we have a diffuse map and a luminous map that we've chosen to add. Let me just turn off luminous. Turn off the color map. We can turn our diffuse off and on as we wish. We can turn our opacity on and off as we wish. So we can make it partially transparent. We can turn our color on and off. We can interactively change it using the color picker, using HSV or RGB, whichever you prefer. We can add a map. And remember, the map once again is multiplied by the color value. Doesn't override it. So if you want your map to be its natural color, then your color needs to be 111, and then you get your original color out of it. We can make the object luminous. We can make it emit light by turning on, for example, PBR. We can change the intensity of the emission. We can add an emit map to change where the light emission is coming from based on a map that we can paint or acquire somehow. We can reflect lights. This is akin to what we know as specular highlights. We can change the size of the specular highlight by changing the blur. We can change the intensity of the specular highlight with the int, of course. We can apply a map as well. We can reflect objects. So for example, this checkerboard down below. We can choose to use intensity and blur parameters that are different from the reflect lights parameters, or we can use the same ones if we want to keep it simple. We can apply a map to reflecting objects as well. We can turn our opacity up and down. Our opacity button simply enables this control. So we can turn our opacity up and down. We can apply a map to opacity as well. That's the stripes map we put on, you recall. We can use refraction. We can enable refraction. We can turn the intensity up and down. We could even put a refraction map in here if we wanted to be consistent. We can interactively change our index of refraction. So now it's inside and outside is both one, so it's like we're just seeing through it as though it's transparent. We can blur the refraction. Actually, let me turn off the diffuse so we can see the refraction better. We can blur the refraction by simply turning up blur. You can see how it becomes blurrier. I'll turn it to a low level so you can see it better. We can turn on our subsurface scattering to get a little bit of light transmission into the material. We can apply a subsurface scattering map. So that's going to tell us where and how much subsurface scattering is happening across the surface. Turn that off. We turn off refraction. I'll turn diffuse back on so we can see things. I'm going to turn off reflect objects. We can turn on displacement. Now there's nothing plugged into displacement now, so you don't see anything, but we can turn on noise. When we turn on displacement noise, we have different kinds of noise that we can use down here. But the really cool thing is that we just turn it on and we get something. We can turn on a map for displacement. What's in the displacement map? Nothing right now. Let's put in that same picture. So this is the picture of me in the biplane, and it's creating a real displacement. We can turn off real displacements, and it just becomes a bump map. Same thing with noise. Or we can turn our real displacements back on as well. We can decide whether we're going to use a bump or a normal map simply by selecting one of these, bump or normal. And we can choose to, well, for example, put in a bump map. And let's go to, looks like our callback isn't quite working for bump map. I'll have to check that out. We can put a bump map in. I'll put the same image in again. And you can see it looks a lot like the displacement map with the true displacement turned off, which is essentially what it is. And of course we can drag our scale up and down. Okay, now we're going to add a refraction map. You'll notice in our interface there is no map for refraction. That's because in the initial Mantra Surface Shader one was not wired in. Pretty straight ahead to wire in though, just like we did for the diffuse map. Well, we need to first find the refraction intensity on our root node here. So we'll look for it here, and we find there's refraction here. Refraction intensity is right here. So simply click on the little button, right click it to expose the input, and it's going to spring way off screen somewhere, so we need to zoom out and find it and drag it back. And we're simply going to do this exact same thing. Remember we did with emission, we had an emit map and a multiply, connected the S and T to the UV inputs. So what we need is this node is the surface color, so we need to add a surface color and a mult node. So once again, tab MUL to add a mult node, and tab SUR to find the surface color node. And the first thing I'll do is I'll pipe the original refraction intensity into the multiply and run that over into the refraction intensity input. And then I'll take this color and add it to the mult. Now we're multiplying properly. I'm going to rename this surface color 1. It's now going to become REFR-MAP, refraction map. And then I need to promote the parameters I want to use for the map and then rearrange them in the interface. And if we use our emit map as a guide, we need 1, 2, 3, 4, 5, 6 parameters. Use color map, base, map wrap, map filter, map width, and map border. So we'll promote all of those. Use map, middle click to promote parameter, and then the same with these other 5. Now, we also have to hook up our S and T coordinates, of course. So in order to do that, I'll simply zoom out, grab our S, connect it to the S input, or the S output, and grab the T, and connect it to the T input. Now, the wiring down here is essentially done. All that remains for us to do now is to rearrange the interface. If we look down at the bottom of our interface, we'll see the new controls are added down there. They're also not named properly. So back into the edit parameter interface, and we're putting this in opacity. There they are. So use color map is going to become use refer map, and we'll just call it map for the purposes of our simplified interface. Base color map becomes base refer map, and this name is actually in the lower interface in the more advanced in the advanced tab, so we can actually use the full word refraction map. For the label, color map wrap becomes refraction map wrap. Color map filter becomes refraction map filter, and the same thing with color map width and color map border. Alright, now these are all renamed. We can move them to the appropriate places in the interface. The use map goes into the upper interface and everything else goes into the lower. So we just have to find our refraction, refract enable. Oh, there we go. It should go right after intensity. And we need to make sure we put our refraction intensity horizontally joined to the next parameter. And then we'll take our other parameters and drop them into the refraction tab. And I would put them right up at the top with a separator. So I actually need to put them, put them right there. Drop a separator in between. And just one thing I noticed, we put inside and outside index of refraction were right at the top of the parameter interface. We have another input for those that we put in. Remember the vector 2. So these don't actually need to be here. We can actually just drop them right down to the bottom. And I'll put their separator in between them as well. And let's take a look at how that looks. Apply it. And refraction. So there's our refraction map. Aha, our enable isn't working because this was originally called a color map. So these parameters are looking for disable when color map is off. So we need to hook up not only our enable but also our callback for this, because this button is not taking us to the refraction tab either. So you may recall that the map interface is called use refer map. So we'll look at each of those, and you see the disable when it's use color map. So we have to switch that to REFR. And then I'll copy and paste that into the other parameters as well. And then we'll find a callback from one of the other parameters, such as, well, let's see, we're looking at refraction here. Refraction intensity, we'll copy its callback script, and we'll put that on the map, which doesn't have one. It looks like we need the disable when also on there. Okay. So now the map button should disable when refraction is off, which it does. Also, when we're in another tab somewhere, it should take us to our refraction tab, which it does. And the refraction map is still not working. Okay, so I have to figure out what's going on there. They should disable when this button is disabled. All of these refraction map controls should disable when this is off. This is fairly typical. Things sometimes don't quite work the way you expect them. So let's take another look and see what's going on. So the parameter for the map is called use. I see the problem. I see the problem right now. This has a lowercase r by accident. I meant to put an uppercase R, and the disable when has an uppercase R. So this should now work properly. There we go. Fairly straightforward. So case is pretty important. So let's enable our IPR and turn off the bump map and see what happens when we put a refraction map in here. Turn refraction up, and we'll turn our refraction blur down to 0. We need index of refraction, of course, so we'll do an inner one of 1.3. Looks like it's refracting fairly well. Our diffuse is up, so let's turn that way down. And if this was glass, it would probably be reflecting a little bit as well. I'll turn reflect objects on, actually. Turn the reflect intensity down, of course. And now let's apply a refraction map and see if this actually works the way we expect it to. So, refraction map, I think we'll use the stripes map to test it, because that's pretty obvious as to whether or not it's working. And yes, indeed, there it is. So you can see the stripes refracting or not refracting. So you can see there's no refraction here, and there is refraction here, and the stripe goes right down the middle. And then we can just turn it off to test whether or not it's working. Flip it on, flip it off. So that works pretty good. So there, now we have a refraction map in our nice long list of maps. And now every channel has a map. Every channel in the upper interface has a map. And that's where we want it to be. Here's a little mistake I made, and it seems to have made it all the way through the video. I don't know how I missed this. It says enable reflection map, and it should be environment reflection map. So we're just going to rename that properly. Edit parameter interface. And where is it here? Enable reflection map should be environment reflection map, ENV. Simple little fixes. And when you're creating your own interface and you go through all of this the first time, you're going to discover little mistakes like this. It's not a big deal. All that matters is that you find all of the issues and continually improve your interface until you have something that works really, really well for you. And if you then export it as an OTL, you can take it with you to places that you work and install it, so that you can, you basically take your toolkit with you into the workplace, because the workplace you go into may not have, the kind of shader interface that you've worked out for yourself. And that's one of the things that's really cool about this software, is that you can save this out as a transportable item and take it with you wherever you go. So we have noise on our displacement channel, and I'll show you that. And I was thinking about also adding noise onto our bump channel, so we could have bump map noise. And that would be fairly straightforward to do. I mean, let's just take a look at the network here and see what the complexities would be. So up here near the top here, let me zoom out so you can see plugging into our surface normal here. If we look up here, we can see we have bump color, and this is where we plug in our bump map, and it goes into the displacement amount. So it'll be pretty straightforward to add a turbulent noise, multiply it by this and going into there, and then have an enable switch on it. Very similar to what we've done already. However, it's kind of already hooked up to do that, and I'll show you exactly how. If we look at, we turn our noise on and have our displacement turned on, we can see that the displacement is occurring because of the noise. And if we look at our, we can change our noise. Let's go to alligator noise and see what that looks like. We can turn down the amplitude to get lower noise. So we have all this nice, really nice true displacement control. And if we want bump maps, all we really have to do is turn off the displacement tab. And you can see that the noise that was applied to displacement now isn't actually displacing. It's acting exactly like a bump map. So we already have noise hooked up in a way that makes it a noise bump map, and that should be just fine. And as a matter of fact, we can do the same thing with an image map as well. So let's find an image to plug into here. Whatever this photograph is, it can be a bump map as well. So honestly, with the ability to turn displacement on and off and make them true displacements or fake displacements, I'm not entirely convinced that we actually need a bump map channel. It may be simply true displacements, not true displacements, aka bump, and normal maps. But that's a decision for you to make. Depends on how you like to work. Some people like to work with displacements and bumps as separate items. And also there's a case to be made for using a displacement with bumps on top of it. So that's a good case for having both. Or you might use displacement with normals on top of it. I guess that's a debate for you to have when you create your own interface. So, but for now, right now, I'm not going to add noise to my bump map because I'm satisfied that I can have it simply by turning it on and turning off my true displacement enable button. Now there's one last thing that I'd really like to take care of in this interface. Unfortunately, I can't right now. And that is, I'd like to add a normal scale, and I'd like to have a normal map and a normal enable over here. However, I'm not going to go to the trouble of doing that because currently normal maps are not working in the matched surface shader, and this is as of Houdini 11 production build 658. So I know SideFX is aware of the problem and they're working on solving it, and hopefully it'll be resolved fairly soon. And in any case, if you're now working with a future version of the matched surface shader in which normal maps are working properly, you should be able to see just by the number of times we've repeated how to add maps and noise and create your enable buttons and so forth. You should be able to go ahead and do that also with your normal map. Okay, one of the real oddities about the mattress surface shader is the way the reflection map is hooked up. You may recall in the original mattress surface shader, we'll just take a look at one of those. They call it the under reflect tab, the reflection mask map. And if we look into the network and try to figure out where that's coming from, here's what we have. We have a reflection mask down here, and it's set up the way a normal map is. There's the use color map and the color map, all the stuff that's in our interface, and it's running through, coming into a mult, and it's going up here into specular color rather than reflection intensity. And if we look at our reflection intensity and we click on it, and let's just expose the input so we can see where that's going. And let's open the parameters to see what this is doing. This is just a float value. So reflection intensity is just going to be a single value across an entire surface. And of course, for artists, what we're looking for is the ability to change the intensity of reflection across a surface using a map. So what I'm suggesting is that the whole reflection mask map thing isn't really either intuitive or particularly functional for artists. So what we need is a reflection map that does something a little bit different than what it currently does. Something that basically what it does in any other software, and that is a map that determines the intensity of reflection across a surface. So let's just go back to our quick shade and take a look at where we're at. So there's specular color coming in there, and again in R1 under reflection intensity, that's where we want to add our new reflection map. But first we kind of need to disconnect the old one and get rid of it. So I'm suggesting that we don't need any of this stuff. I'm not going to delete it right now. I'm simply going to disconnect it. So just right click, disconnect that from the mult, which means the other values going to the specular input, specular color, are just going to go straight through. Now we're going to come back to this network as well, because a lot of this stuff isn't working really very well either. This is where our spec map is coming through, and once again, as I mentioned earlier, the specular map, rather than determining the intensity of specularity across the surface as it should do, is adding color of specularity into a surface. So once again, specular intensity is just a single value across an entire surface, and you only change the color. This could be seen as a more advanced way of doing specular intensity, because of course color has value, and if you have a lower value you'll have less specular intensity. So we'll talk about the pros and cons of that versus straight specular intensity, which is basically just value, whereas specular color of course is RGB or HSV, whichever way you want to think about it. So back to our reflect objects map. So remember, they're calling specular now, they're calling it reflect lights, and reflection, they're now calling it reflect objects. So here's our reflection intensity. Once again, we'll expose that input. Pull it back over to where we can work on it. And once again, we're going to add a mult and a map. Starting to get a little bit busy in here. We can make a little bit of space by, I can middle click on this node, for example, and hide the input nodes. And it turns back into the little button. It helps clean things up a little bit. Make a little bit of space for us. Okay, and we'll add the surface color. and the mult node, multiply, and once again we'll pipe reflection intensity straight into multiply right away. And multiply by the surface color here. And this surface color node is immediately going to get named reflection map. And we'll promote those 6 parameters, that our 6 common parameters. And then we need to hook up our SMT. Okay, once again, we're done with our basic wiring down here. U to go back up, and then we'll look at our parameter interface where we should find all our parameters at the bottom. We do. We need to rename these, and then we need to rearrange them in our interface. Back to the edit parameter interface, and we'll start renaming. Use color map 1 becomes use REFL map. And of course, our label, it becomes simply map again. And I'll just pause this while I rename these, so you've seen me do that enough time. Okay, so I've renamed everything from color map to reflection map. Basically just put reflection or REFL wherever it used to say color. And I've added the correct disable when scripts and the correct callback scripts. And now all that remains is for us to rearrange these into the proper location. So the use map for reflection is actually going to go where the current one, there already is one, and it is, there's reflect lights, there it is, use reflection mask. So we're going to put this in ahead of that, use reflect, right ahead of reflection mask. And we're actually going to delete this one because we don't want to use this one anymore. Now, as to the reflect objects interface, this is where we have all the current reflection map stuff. We don't need it anymore either. So we're actually going to take our new interface parameters, put them up there, and then we're going to delete these ones. Now when we look at our interface, we see that the reflection tab has the new reflection map parameters in it. And when we turn on reflect objects and map, those will all become enabled. So let's look and see if this actually works now. So we'll re-enable our render view. And so I've turned reflect objects on. I'm going to turn the intensity up nice and high so we can see it. And for map, I'm going to use the stripes map again. Stripes. So there we go. Now we can see that the stripes map is working perfectly. I should just add another light to this scene so we can see it a little bit better. Just drop a point light down over on this side. And have a look at our render view again. So yeah, you can see that stripe is over here. I should probably put thinner stripes in that so we can see it a little bit better, but you can see very clearly how it's working. So that's it for our reflect objects map. Now our reflect objects map works on intensity rather than into the specular color channel, and it works exactly as we would intuitively expect it to work. And we need to do this also with the reflect lights map as well. So let's take a look at that and see what it's doing right now. The reflect lights map adds a mapped color into the specularity rather than determining where specularity is on and off. Let's just put our striped map in and see how that compares rather than a colored image. Well, I don't think that striped image has enough stripes on it, so let's switch. I've done an image with even more stripes on it. I've called it stripes 2. Let's take a look at that. Okay. So that is showing us that specularity intensity is being managed by the specularity map. Let me just actually should show you what that map looks like in comparison to the previous one. So you see it has a lot more stripes on it wrapping around. So you can see that putting a black and white image into the specular color channel basically works the same as if we were to wire it just into the specular intensity channel. And the main difference between intensity and color is like the same between diffuse and color. Intensity is the brightness and darkness of the channel, and then color is RGB values. So brightness and darkness controls all three RGB and value equally at the same time, and color controls RGB and B as separate channels. So with that in mind, we should be able to put a black and white image into our specular map, and it'll be shunted into specular color, but it will still control it as though it is specular intensity. So it's a little bit unusual way of thinking about it, but when you think about it this way, what you realize now is that you have the added functionality of being able to put a color map into the specular map. So you can control not only the intensity of the specular highlights, but also the color of them across a surface. And that presents us with a lot of interesting possibilities. So with that in mind, I don't think we really need to make any wiring changes to the specular map. I think it's perfectly functional as it is, and in fact even a little bit more functional than the kind of specular map input that we're accustomed to in other software packages. Okay, one of the things that I find quite useful is a little bit of procedural noise. And one of the really good places, I mean, ideally we'd have procedural noise in every single channel, but this video isn't actually going to be long enough to do it in every channel, so we'll show you how to do it in a couple of channels, starting with the diffuse channel. Diffuse is a really common place to put a little bit of procedural noise. Sometimes you want to dirty things up a little bit, add a little bit of organic mess to it. And a procedural noise can be really good for that. So in the same way as we have map here, it'd be great to have just a little noise button, just noise on and off, and then down here in the diffuse tab have under diffuse map would have the noise and all of its various channels. So let's go ahead and take a look at the network and how we might do that. So first, we know we want to apply it to diffuse intensity, and this is where we put our diffuse map. So we have diffuse intensity multiplied by diffuse map, and there's another next input sitting right there, and we could plug anything into that. So why don't we multiply it by procedural noise? Pretty straightforward. First, let's make ourselves a little bit of space. Hide some of these inputs. Move things around to give us a little bit of real estate. So, first thing we want to do is add a turbulent noise node. So, tab TUR turbulent noise. And the turbulent noise is going to plug directly into the next input. So now we have a turbulent noise. So what we need to determine is what parameters we want to put in the interface and what the position of the noise on the object is going to be. So we need a global P position node, and those are all over the place. Here's one way you can add nodes. You can simply copy and paste. So for example, you might find a global P which is global position. If we look at the parameters for that node, we can see that it belongs to a surface and it's outputting the surface position. But it's a global position. What this means is if we use this to apply turbulence to our surface, if the surface moves through space, the turbulence will kind of wash over the surface. But it's we can actually transform this from world space into object space, and I'll show you how. But so we can just copy this, Control C, and we can go back up here where we're building our turbulent noise, and we can paste it. So there it is. Now it's currently world space. We want to transform it into object space. Tab TR for transform. And if we look at the properties for this, again type P, not the properties, the parameters for this, type P, and we can see that it's going from current space, so whatever space we're putting in, and that is world space, to object space. So by default it's what we want it to be, and we're going to plug that straight into position. So now the turbulent noise should stick to the object wherever it's going. Now these other parameters we would like to promote to the interface: noise type, frequency, offset, amplitude, roughness, attenuation, turbulence. Basically those are what the noise is going to look like. So we want to be able to fool around with those in the interface. But if we look at the way we've wired our network, we can see that the intensity and the diffuse map and the turbulent noise are always going to multiply by each other. We have use color map here, but we have no way of turning our turbulent noise off. So what we need is some kind of a switch. And there's like tons of different ways to do this. Here's one. We can add another surface color noise and plug the noise output into the color map, into the base color map, and then simply say use color map and promote that use button. So let's try that. I'll show you what I mean. So we add a surface color. This will go into the base color. The output of that will go into the mult. And then we'll promote the use base color to the interface. So now this node will tell us whether or not to use the turbulent noise. So first of all, before we add the turbulent noise parameters, let's go ahead and add this one. Rename it and put it in the proper place. You can see if we go up, it'll be at the bottom of our interface, and it's called use base color again. So we need to rename it. This is going to be called noise, and we're going to rename it use diff noise. And then we need to move it way up near the top here. Right before map. And then of course we need to turn on the horizontally join. Oop, wrong one. Noise. And we need to add the disable one and the callback. So that should be ready to go. So there it is. There's our noise button in there. And so far we have no parameters down here for noise. So let's go ahead and add those back into the network. So to our turbulent noise, we'll just promote these several parameters. So there's our new parameters for the diffuse noise. And we should name these diff noise turbulence. I want to use capital letters to separate our words. Take that one off the end. And we can leave the labels the same because they'll be inside the diffuse tab, so we'll know what they mean. So the next thing is for us to go ahead and grab all these parameters, the noise parameters for the diffuse noise, and put them up in the diffuse tab. They should go underneath map. Once again, I can't put them right at the bottom. They'll end up in the wrong hierarchical position, so I have to put them under the second to the last one, and then move the second to the last one back up where it belongs. Fortunately, these are named diff map, and the other ones are named diff noise, so I can tell the difference. I'm going to stick a separator in between them. And I'm actually going to take these ordinary roughness and diffuse minimum, and I'm going to put them at the bottom. So a little bit cryptic. There we go again. I can't really put them at the bottom. I need to put them not quite at the bottom, and then move the bottom one back into position. There we go. Now our interface is all in position, as we can see. So let's try this out and see if it works. We'll go to our render view, enable the render, see what we get. So there it is without the noise turned on, and we'll turn noise on now. And we immediately get a noise. So it goes to the diffuse tab, noise is enabled. We can switch noise types in here. And obviously we can change our amplitudes, attenuation, turbulence, all the various channels. So using our render view, we can interactively change this to get the noise layer that we want. And not only that, but it multiplies by the intensity setting. It also multiplies by whatever map we choose. So let's stick the striped map on there. So there we go. So we can see our stripes is multiplying by both the diffuse intensity on the slider and by the noise. So now we have noise in our diffuse channel as well. And there you have it. Okay, since we are essentially done setting up our interface, we have all our callbacks and all our disable when buttons set that we want them to. What we would like to do is go through and set a bunch of defaults. So this is where your preferences really come into play. How do you like certain channels to be set automatically? When you load the shader on, you want the material to work in a certain specific way. So you can set all of your own defaults. And once again, we do that from within the edit parameter interface. So we know that when a parameter is not at its default, it becomes bold. Reflect lights, opacity, displacement. These values are not at their defaults. We can set them at their defaults, of course, by right-clicking and saying revert to defaults. And those are the defaults that came with the Mantra surface shader. And those may or may not be the defaults that you would like to have for your shader. So for example, I would expect we would want diffuse on all the time. And it is in the defaults. You can tell by going to that parameter, diff enable, and you can look at the numeric defaults. If it's a toggle, the toggle default is on. And the intensity is 0.5. So diffuse intensity at 0.5 means that no matter what light you shine on this material, it's only going to reflect back half of that. And since it's multiplied with color, if you put a color map on there, it's only going to give you half of that. So you have to decide if that's what you want. If you'd like a pure natural color, you set your numeric default of intensity. There it is. There's your float default of half. You could set it something higher. Personally, I would set it at about 0.8. And the reason why I wouldn't set it at 1 is because of the nature of the CG lights we use. We tend to use lights without fall off on them, which means they're far brighter than they actually should be when they're touching the material. We're working in linear color space, so our materials tend to be blown out before we get any maps onto them. So it's a good idea to have your intensity a little bit low, and you can do that either through intensity or through color. You could set these to 1 and these to 0.8. It actually amounts to the same thing. However, if this defaults to 0.8, then if you add a color map, it'll never be its true color until you change these up to 1. It's a bit of a nightmare. So I would tend to leave color at 1. I would tend to leave color on, and I would set diffuse on and in its intensity to 0.8. I would have noise and map off by default, and you can see that the noise default, let's set it, revert it to default, it's on by default, so I would like that to be off. So I'm going to set its toggle default to off and apply that. There we go. Luminous I would have be off by default. Emit light looks like it would normally be on by default, so I would like that to be off. And what's the intensity? Emit intensity of 1. I think that's good. If you turn on luminous by accident, even you're trying to switch something, you switch something else, you want it to be immediately obvious. So I think an intensity of 1 is good. Not having a map is correct. Reflect lights on by default I think is good. Let's see what its default intensity is 0.1, and its blur default is 10. So what this means is that the specular highlight from lights is going to be quite low in intensity and quite large. And for starting out, I mean, you have to decide this, but that's probably not a bad way to start out. If the blur is too low, you're not going to see the specular highlight very well. And remember that a high blur simulates a light source that's larger than a point light, which actually is a zero-dimensional in size. So that's not a bad way to start. It means you're going to immediately have a visible specular highlight. There'll be no ambiguity about what that is. And that's one thing that we really want to strive for in defaults, is that there's no ambiguity about when something is turned off or on. So we also have reflect objects. I would have that off by default. And I would also have separate object parameters off by default, which it is. Let's see what the defaults are here are. 0.1 and 0. You know, I would set the intensity to at least 50% for the reflect intensity, because I think 10% might get missed, and I don't want there to be any question about when we turn on reflect objects. So I'm going to go down to my reflect objects intensity and set its default to 0.5. And I'll turn those off so they're off by default. The environment reflection map, the map itself should be off by default. Oh, right, I remember those are the same button. The map is off by default, and the tint is to 1, which means there will be no color change by default, and we want that. Opacity should be probably, let's see, I would disable that by default. So enable opacity button needs to have its default set to 0, and since this is a toggle that we added, we need to go to its channel tab, and it's saying, asking what the default is. The default is 0 for off. I'll apply that. And a scale of 1 for opacity is good. It means the material is going to be completely opaque to begin with, and we want that. Refraction is off by default, that's good. Its intensity is 1, that's good. Nice high value, so when you turn refraction on, there's no question. Map is off by default, that's good. Index of refraction defaults, I The normal Houdini default is 1.2. I prefer 1.3, and we actually need to set that in the refract panel here. So the default inside is 1.2. I like 1.3 because that is the refractive index for glass, and water is pretty close to that as well. So it's very common, most commonly used as a matter of fact. Subsurface scattering is off by default. That's good. Its intensity is nice and high. Let's see if that's the right default here. I would put that intensity to 1. Once again, I don't want there to be any ambiguity. So subsurface scattering intensity, default of 1. And then as you start to use this interface, and you may discover that there are other defaults that work better, and the beauty is now you know how to make your own interface work for yourself, so you get to go and change your defaults and refine and massage this interface until it's absolutely awesome. Alright, displace is on by default. I think it should be off. I don't think we want displacements on by default at all. And the scale is very low. So I'd do at least, let's see, display scale 0.05. Let's try 0.2. Once again, no ambiguity. We want to know for certain. I have to say, I said it in the wrong place. We want to know for certain displacement is happening. Noise and map should be off by default. Fake displacement is set to none by default. And use bump map is off by default. What's the default for bump scale? 10%. That's probably not bad. And if we have normal map, it should also be off by default, which it is. Alright. So we've completely rearranged our interface to create a quick shade interface that allows us instant access to all of this information without having to go through a bunch of tabs. We've set it up so that tabs open automatically when we access parameters. And we've set our defaults into a range that we think will work to begin with. And we furthermore have the ability to go ahead and continue to refine the shader until it's working really, really well. So now that our shader interface, basically version 1, is done, we want to be able to create an OTL out of it. An OTL is a transportable unit. It's a digital asset, and it's something that you can take to another computer and install into another Houdini. So it's transportable. You can take it with you. You can give it to friends. You can pass it around. And in fact, this OTL is going to be available for download with this training video. Really easy to make an OTL. Simply right click on it, and actually let me maximize this so you can see that whole menu. Down here we have create digital asset. Very simple. Operator's name is, I'm just going to call it quick shade. Underscore version 01. And I'm going to save it on my desktop. And I'm going to call it quick shade version 01.otl. And it's automatically going to install it into our library. We're going to get this warning error when we export our OTL. We'll just say no changes. And now, when we're inside our shop, when we go tab, there's our quick shade version 1. And when we look at it, there it is, ready to roll. Just exactly as we have designed it. So the very last thing you need to know about your OTL is how to install it into a fresh scene. So you open up a fresh scene. This is totally fresh. I just added a grid and a sphere. You simply go File, Install Digital Asset Library. Now remember, I put mine on my desktop. So I'm just going to look on my desktop. And there it is, QuickShade version 1.otl, accept. And now it's installed in my system. So now when I go to my shop, I can hit Tab, Q, and there's QuickShade version 1 in a totally fresh scene. I can add it, and there's my interface. And away we go.